It's February 13, 2026, and let's get right into the day. You guys remember that one? Anyway, let's start with probably the most technically significant announcement of the week, that on Thursday, that's today, OpenAI released a new model called GPT 5.3 Codex Spark. On its own, that would be a routine product launch, but what makes this release remarkable is the hardware it runs on. For the first time ever in OpenAI's history, a production model is being served on chips that are not made by Nvidia. Instead, Codex Spark runs on the Wafer Scale Engine 3, a processor built by a company called Cerebras Systems. And so to understand why this matters, you need to understand what Cerebras does differently. Traditional AI chips like Nvidia's H100 or B200 graphics cards are cut from silicon wafers into many individual processors. These processors are then connected together using high-speed networks to form a cluster. Every time data moves between these chips, it creates a small delay. Cerebras took a completely different approach here. They use the entire silicon wafer uncut as a single massive processor. The Wafer Scale Engine 3 contains 4 trillion transistors and a very large amount of on-chip memory. Because the data does not need to travel between separate chips, the latency is dramatically lower. The result is speed. OpenAI says Codex Spark can generate more than 1,000 tokens per second. To put that into context, the full GPT 5.3 Codex model operates at approximately 65 tokens per second. That is roughly a 15 times improvement. Now, OpenAI was careful to say that Nvidia remains foundational to its training and inference operations, but the Cerebras partnership, announced in January as a deal worth over $10 billion, is clearly designed for workloads where low latency matters most. OpenAI has also signed agreements with AMD and Broadcom for additional chip supply. It is not a replacement of Nvidia, it is the beginning of a hardware diversification era where different chips serve different workloads. That shift has significant implications for the semiconductor industry. Our second story is about money, and the numbers are extraordinary. Today, Anthropic announced that it is close to a $30 billion Series G funding round. That values the company at about maybe $380 billion. To be clear about the scale, this is the second largest private technology financing round in history. The only larger one was OpenAI's raise of over $40 billion in 2025. Now, this round was led by the Singapore Sovereign Wealth Fund, GIC, and the investment firm Couture, and co-led by D.E. Shaw Ventures, Peter Thiel's Founders Fund, Iconic Capital, and Abu Dhabi's MGX. It also includes portions of the previously announced investment from Microsoft and Nvidia. With this round, Anthropic has raised nearly $64 billion since its founding in 2021 by a group of former OpenAI researchers. So what's driving this valuation? Revenue growth. Anthropic disclosed that its annualized revenue run rate has reached $14 billion. That figure has grown more than 10 times annually in each of the past 3 years. The number of customers spending over $100,000 per year has grown 7 times in the past 12 months. A large portion of this growth comes from a single product, Claude Code. Claude Code's annualized revenue has grown to over $2.5 billion, more than doubling since the start of 2026. Business subscriptions to Claude Code have quadrupled in that same period, and enterprise customers now represent more than half of Claude Code customers. This valuation places Anthropic alongside OpenAI and SpaceX as one of the 3 most valuable private companies in the world. Analysts are now watching closely to see which of these will pursue initial public offering first. IPOs, baby! Get your money ready! Now, the third story connects directly to the first two, and it may be the most strategically important development of the week. In a conversation with the Financial Times published this week, Mustafa Suleyman, the head of Microsoft AI, confirmed that Microsoft is building its own frontier-grade AI foundational model. Goal, in his words, is to achieve true self-sufficiency in artificial intelligence and reduce the company's dependence on OpenAI. This is a significant shift. Since 2019, Microsoft has invested over $13 billion in OpenAI. The company's entire AI product line, including Microsoft 365 Copilot and GitHub Copilot, runs on OpenAI's models. Microsoft restructured its relationships with OpenAI in October 2025, and both companies gained more flexibility. Microsoft plans to release internal models, referred to as the MAI series, sometime in 2026. To support this, the company has developed the Maya 200, its second-generation custom AI chip. We're seeing a lot of people developing their own AI chips, or pivoting away from Nvidia for specific tasks. And it's also building new data centers. Microsoft's capital expenditure forecast for the fiscal year ending in June is $140 billion. This matters for several reasons. First, it makes Microsoft a direct competitor to OpenAI as opposed to a partner. Second, it raises questions about OpenAI's long-term financial position. OpenAI is reportedly seeking an additional $100 billion in funding, which would push its valuation to $830 billion. But if its largest commercial partner is actively reducing its dependence on OpenAI's technology, the revenue assumption behind that valuation becomes a little harder to justify. Third, it intensifies the competition in AI foundational models. Google has Gemini, Meta has Llama, now Microsoft is entering that race independently, and the market for frontier AI is becoming more crowded, not less. And the fourth and final story takes us to a different direction, toward a new approach to AI hardware that could eventually reshape how inference is done. A London-based startup called Olix Computing, founded in 2024 by 25-year-old James DeCombe, has raised $220 million in new funding. The round was led by Belgian venture capital firm Hummingbird Ventures, and it values Olix at over $1 billion. The company has now raised approximately $250 million in total, and I've never heard of it before. Olix is building what it calls optical tensor processing units. It's a new type of chip that uses photonics, meaning it uses light instead of electrical signals to move data within the processor. To understand why this is interesting, you need to understand a problem called the memory wall. Current AI chips, including Nvidia's GPUs, rely on a type of external memory called high bandwidth memory. When a chip performs a calculation, it loads data from the HBM into its faster internal cache, processes it, and writes the results back to the HBM. Each of these transfers takes time and energy. As AI models grow larger and inference workloads become more demanding, this data movement becomes the primary bottleneck, not the raw processing power of the chip itself. So Olix claims that his architecture addresses this by combining an SRAM-based memory design with photonic interconnects. SRAM is the fast internal memory that sits directly on a chip. It's much faster than HBM, but traditionally available in much smaller quantities. Olix says its photonic technology allows it to scale SRAM architectures more effectively, avoiding HBM entirely. The company claims this delivers better throughput per megawatt and lower total cost than current GPU systems. It also avoids the supply chain constraints around HBM that are limiting the industry right now. Olix, despite its giant valuation and raise, has not yet shipped the product. The company expects to deliver its first chips to customers in 2027. Many startups have attempted to challenge Nvidia's dominance in AI hardware, and most have failed to gain meaningful market share. Cerebras, which we discussed earlier, is one of the few that has secured a major production partnership. But the photonic approach is worth paying attention to because it attacks a fundamental physical limitation. Light travels faster than electrical signals and generates less heat. If Olix can deliver on its claims, it represents a genuinely different approach to the inference cost problem, which is currently one of the largest economic constraints facing the AI industry. So what connects these four stories? Diversification! OpenAI is diversifying away from Nvidia, Anthropic is diversifying its investor base and revenue streams, Microsoft is diversifying away from OpenAI, and startups like Olix are attempting to diversify the fundamental technology used in AI chips. The AI industry in 2026 is entering a phase where the partnerships and dependencies of the last 3 years are being actively restructured. The companies that control the next generation of infrastructure will determine who leads in the next phase of artificial intelligence. That's February 13, 2026. Boom! Like and subscribe. I'll see you in the next one.